Okay, this is the front side of the homework problems from the book that I didn't have time to go over. So the first question talks about writing story problems that go with the two definition of division. And so the first one is how many groups, and then the other one is how many in a group. So if they're groups, I want my units to match so they cancel and spit out how many groups. So for example, if I have 63 suckers and I give 7 suckers to all my friends, how many friends could I give suckers to, or how many groups? And so then what you would do is you would put 7 in a pile, that'd be one group, and you put 7 in another pile, that'd be another group, and you keep doing that until all the suckers were gone. And so if I keep going, and again the book gave us lovely long numbers. Let's see, 1, 2, 7. We should have 9 total here. So I think I need one more. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would have 9 groups or 9 friends that I could give suckers to. If it's how many in a group, then my units don't match. So I have 63 cookies, 7 friends. How many cookies does each friend get? So in this case, you would go ahead and draw your 7 friends there. And then you would give, a cookie, a cookie, a cookie, and so forth, until they couldn't work out. So you give, a cookie, 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 and then you keep doing that till all 63 run out. So eventually, you keep going, everyone will end up with 9 cookies in the group. I'm just going to switch to dots. Okay, and so the answer here is 9 because I have 1, 2, 3, 4, 9 groups. Here the answer is 9 because they get 9 cookies. The next question talks about 21 divided by 3. If you used an array, so that would be you have 21 cans and they're in an array that is 3 wide. So I have 21 cans and they're in 3 rows. How many would be in each row? Or if I have 3 columns or 3 rows, however you want to word that. And so then you would know that you would have to have 7 columns of 3, so that's at 4. So if this is 3 and this is 21, then I would know that this missing side would have to be 7. Right, so you need to word it something about like 21 cookies arranged in 3 rows. How many cookies are in each row, or how many columns would there be, something like that. Where an area model, you would have 3, and then you'd have 21 squares lined up. Okay, so you'd have something like a rectangle has an area of 21 square inches, the width is 3 inches. What is the length? Something along those lines. All right, the next problem is looking at finding the factors of these numbers. And it also says, how do you know when you're done? So some of you said you're done when you repeat, but in reality, you're done when you hit the square root of the number, right? So the square root of this, the square root of 81 is 9, 64 is 8. So if you check 3, 4, 5, 6, 7, 8, and even 8, you're probably done. You're going to be fine. All right, so 1 and 63. 2 is even, so it doesn't work. So 4 is not going to work, 6 not going to work, 8 is not going to work. The pen's not looking very good on this side. All right, and so 6 plus 3 adds up to 9, so 3 goes in there. 5, that's problematic because it doesn't end in a 0 or 5. And then 7 you need to check, and so again there is a trick for 7, otherwise you just divide. And so right here I know that I have all the factors of 63 because I checked through the square root. 75, same thing. Hopefully the pen works a little bit better over here. Okay, 9 times 9 is 81. That's too big, so 8 is good enough. Again, 1 works. 2, it's not even, so none of the even numbers will work. 3, add up the digits, so 7, and that adds up to 12, so 3 works. 5, it ends in a 5, so that works. All right, and then through 126, I would check through the square root. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 is 144, 12 times 12, so checking through 11. 11 times 11 is 121, so that's good enough. And I get 126. Add up the, well, oh, sorry, first even. Well, obviously it ends in a even number, so we have 63, so I just divide. And let's see, 3, add up the digits, that works as well, so I divide and get 42. 4, you look at the last 2 digits. 4 does not go into 26, so 4 is out. 5 doesn't end in a 0, 5, it's out. 2 and 3 both work, so 6 must work, so divide and get 21. 7, you just have to flat out divide, so you have to, again, unless you know the trick, which I don't. All right, so 7 is 18. And then 8, you might be tempted to be like, well, 2 works and maybe 4 or whatever, you have to check. But obviously 4 doesn't work, so 8 can't. But just because 4 does work and 2 works, remember 2 is part of 4, so that doesn't even guarantee that 8 is going to work. Right? With 8, you have to look at the last 3 digits, but it's a 3-digit number anyway. So if you want to do long division, you can, but since 4 doesn't go into it, you're kind of guaranteed 8 won't. And then 9, add up the digits, 9 goes in there, so we're good there. Right? And then again, for the second part of the question, it asks you to write like how you know when to stop. And again, the answer should be as long as you check through the square root, you're good. Again, some of you said if you check until it starts repeating factors, which is true, but that might take you a while sometimes. All right, the next one, it says write a problem that would ask for the factors of 48. I would say something like, what are the dimensions of all the rectangles you can make with 48 square tiles? So like 1 by 48, 2 by 24, and so forth. As far as every 15 and wanting multiples, saying something about a bell rings every 15 minutes. When will it ring the next 3 times? Okay, because I think they said they wanted you to give the next 3 multiples, something along that line. All right, the next one we did together in class. Let me put this down, sorry. Remember these two, there's 2 sets of them, so no matter if there's odd or even, I know that's going to even up. And so there's 5 here, so I know that that number has to be odd because these 2 are even and there's an odd number in the middle. And same thing here, like these 2 would pair up making an even, those 2 would pair up and even. So again, I have one string that's out there, and so if I count how many are in there, I believe there was 7 in there. So the whole number is odd because these guys would make an even, but then that one would be odd. Right, the next one talks about taking an even times 3 plus 1. So like an example would be like 8 times 3 plus 1, 24 plus 1 is 25. And so it looks like it's always going to be odd because an even times an odd is going to give you an even, and one more than an even is an odd. If we look at this from algebra, an even looks like that, always has a factor of 2. And so then if I multiply this, I get 6x plus 1, which is just 2 times 3x plus 1. And again, remember, if you have a factor of 2, it's even. So this is guaranteed to be even, and the definition of odd is 1 more than that. So this always is going to have to be odd. The next one talked about adding up all the digits and, you know, it should be divisible or not. All right. And so if you look at that number, it's a really long number. It's this is not a bunch of little numbers. It is a long number, and it's divided by 3. And so if you look, this is 6 plus 6 plus 6 plus 6 plus 6. So it's definitely going to be divisible by 3. When I add up all the digits, they add up to 30, and 30 is definitely divisible by 3. So I know that the whole number has to go in there perfect. The problem is that they used a calculator, so the calculator, it's too long of a number for the calculator, and so the calculator is shoving it into scientific notation, saying that the exponent of 10 is this. But the reality is 3 really divides into that number. If you did long division, you could get it to work with no remainder. And then the next one is talking about different things. So it says, if a whole number is divisible by both 6 and 2, is it necessarily divisible by 12? So if you think of like 18, 18 is divisible by 2. And let's see, 18 is also divisible by 3. All right, but is it, let's see, what was it? Oh, 6, I'm sorry. Yeah, it's also divisible by 6, which is 2. But 18 is not divisible by 12. Okay, it won't go in there perfectly. So 6 goes in, 2 goes in, but 12 won't. Part B says, if a whole number is divisible by both 3 and 4, is it necessarily divisible by 12? All right, so say, I don't know, a whole number divisible by 3 and 4. So say I try 36. 36 is divisible by 3, that's good. 36 is divisible by 4, which is that good. And 36 is divisible by 12. So it seems like, you know, maybe it works. We don't have enough evidence to prove it right now, but it seems to be. Okay, so C, based on your example, again, I would say A is a no, it doesn't work. And B, I would say yes, based on what I picked, it seems to work. And then D says, based on your answers to C, determine whether blah, 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 blah is divisible by 12 without using calculator or doing long division. Explain your reasoning. All right. So again, that's a really long number, 321, dot, 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 and so forth. So if you look in your book on page 329, you know, that's one really long number. All right. And so if I add up all the digits, I ended up getting 60, and 60 is divisible by 3. So 3 works. So 3 is a factor of that. 3 divides in there. And then if you look at the last 2 digits, the end of that number was 516. And so to check for 4, I would take 16 goes in there, right? So 4 works. For the divisibility rule for 4, you just look at the last 2 digits. So both 3 and 4 works. So I would say that yes, 12 will work. And the reason that is because up here, this 2 is part of that 6. And so that's why you can come up with examples where it doesn't work, because you're already kind of, in a sense, double counting the 2 as part of the 6. Where here, if you look at 3 and 4, they have nothing in common. And so if a number is divisible by 4 and 3, there's no way you could be double counting any factors, because 4 has nothing in common with 3, right? And so that's why if 3 works and 4 works, 12 is definitely going to work. All right, that's the front side, and then I'll go over the back side.